What is up, engine heads? Welcome to another episode of Boost School, the YouTube University course on Boost made possible by the good people over at AEM Electronics. A while ago we did a historical video on the turbocharger, but as you know, the turbo isn't the only way of force feeding extra air into your engine. There's that other thing, the one that makes the whining sound, the supercharger, and today we're giving the historical treatment to the supercharger. So sit back, relax, and together let's travel back in time to see how the world received the blessing of the supercharger. The beginnings of the supercharger actually precede the birth of the internal combustion engine and date all the way back to 1860, when two brothers, Philander and Francis Marion Roots, the surname already probably rings a bell, right? Well, these two brothers patented something they called a Roots rotary air blower. The Roots air blower consisted of two shafts with large lobes on them that rotated in opposite direction with tight clearances between them, and by doing so were capable of forcing out large amounts of air far more efficiently and far faster than any machine before. But the original application of the Roots air blower had nothing to do with the automotive world, mostly because the automobile as we know it today wasn't even invented yet, nor was the four-stroke internal combustion engine, which explains why the application of the first ever supercharger was purely industrial. The Roots air blower was key for dramatically improving and speeding up the process of melting and production of iron, lead, copper, and other metals which were made using blast furnaces. In contrast to an air furnace which operates at atmospheric pressure, a blast furnace relies on compressed air to achieve higher temperatures and speed up the transformation of ores into metals. The Roots air blower was capable of delivering much greater quantities of air much faster, and it made the machines that were used before for this purpose, the leather bellows and the cast iron blowing cylinders, look absolutely ridiculous. The other very common application of the Roots air blower was the ventilation of underground mines, where it was used to provide miners with fresh air. But what about the first supercharger attached to an actual internal combustion engine? Well, interestingly enough, the first such usage of a supercharger actually coincides with the invention of the two-stroke engine. In 1878, just 2 years after the world was introduced to the first functioning four-stroke engine, Scottish engineer Dougal Clerk unveiled the first functioning two-stroke engine. Now you might be wondering, why would the first two-stroke engine even need a supercharger? Well, to understand that, we have to take a closer look at Dougal's design. And upon seeing it, you might jump the gun and say, how cool, it's a V engine. Actually, no, it's not a V engine. This is the supercharger, and the reason why I'm using air quotes when I talk about it, this is actually a compression cylinder of sorts, but it does the same thing and works kind of the same way as a modern supercharger. It's driven by the engine via this sleeve connecting rod, and although the design doesn't resemble any modern supercharger design because it uses a piston to compress the air, at the end of the day it does the same thing. It compresses the air, it's driven by the engine, and it sends the air into the engine. This is also the reason why Dougal's two-stroke engine actually had poppet inlet valves, automatic inlet valves, which allow the entry of the compressed air from the supercharger into the engine. Dougal's two-stroke actually needed the supercharger to compress the air for it because his engine didn't use the downward motion of the piston to compress the air and fuel like modern two-stroke engines do. The two-stroke as we know it today, which works like this, was invented later by Englishman James Day, for which he received patents in 1891. What about the first ever supercharged four-stroke engine? Well, for that, some people actually credit Gottlieb Daimler. Yes, that man that played a key part in the creation of Mercedes. The claim is based on his first ever engine, the grandfather clock engine, which was patented in 1885. In German, this engine was called Standuhr, literally translated meaning standing clock, based on the engine's very upright and very tall design. Now, this engine was later installed into a wooden two-wheeler, which is widely considered as the first ever motorcycle, although it had training wheels on it. Now, the big deal with the first initial versions of this engine is that they had a valve in the piston, and this valve allowed the transfer of some of the charge back into the intake to allow a greater pressure in the intake than the engine engine could achieve alone at atmospheric pressure. Whether this worked and to what extent is actually up for debate. But more importantly than this, some sources also cite Gottlieb Daimler as being the first person to install and experiment with a Roots-type supercharger on an internal combustion engine in 1900. Now, the company itself, Daimler AG, does not make any open claims to this fact, so it's up for speculation. It's also up for speculation because Gottlieb actually died in the same year in 1900 on the 6th of March. But what is definitely not up for speculation is that Gottlieb's son, eldest son, Paul Daimler, was absolutely instrumental in creating the first ever series production supercharged cars. They were unveiled at the Berlin International Automobile Exhibition in 1921, and they were called Mercedes 620 horsepower and Mercedes 1035 horsepower. Both of these cars had 4-stroke, 4-cylinder engines in them, and these engines had Roots-type superchargers installed on them. What's also kind of interesting to observe is the naming convention of these early Mercedes cars. The horsepower output is the name of the car. The first number is the fiscal horsepower, or the taxable horsepower in Germany back then, and this is largely based on the bore and stroke of the engine, and the second number is the actual horsepower of the engine. Serial production of these cars started in 1923, and this is when their names were changed and expanded into 62538 and 104065. The third number now denoted the horsepower output of the engine when the supercharger was doing its thing. So if we look at the relatively low displacement of these engines, these were really impressive power figures for the time. It's also interesting to observe how the supercharger increased power output by around 50%. So superchargers were serious power adders from day one. Speaking of serious power adders, they're kinda useless without serious power management, and today we make sure to make the most of our power adders by using the right standalone ECUs. So if you want to add power the smart way and have access to an almost infinite number of very smart, very effective, easy to implement and user-friendly tuning strategies, definitely check out AEM's Infinity ECUs. Links are below. Now back to the 1920s. What's really impressive about these Mercedes vehicles is how they managed to make supercharging technology usable and reliable in normal road-going serial production cars. Supercharging engines with the technology available back in those days was very hard and very expensive, which explains why every other supercharged car in the early 20s was actually a racing car. Although these Mercedes cars are historically very important, they were a bit of a commercial failure. The supercharging thing ultimately resulted in a very high price tag, which resulted in modest sales, and the production of these cars ended after just 1 year on the market. Of course, Mercedes continued to churn out some very impressive supercharged cars, but the first ever examples set the tone for supercharging for pretty much the rest of history. Supercharging would most often be reserved for pretty special, high-end, pretty expensive, high-performance cars. But what about other supercharger types, the screw-type supercharger, for example? Well, the invention of the screw-type supercharger is actually also linked to blast furnaces and the melting of metals. The idea of the screw-type supercharger actually belongs to one Heinrich Krieger in Germany. He was an expert on the design of blast furnaces, and he realized that new types of furnaces needed more and more air to do their job. So he decided to improve the original Roots blower design by incorporating a twist to the lobes, thus creating a sort of a twisted or screwed shape. Now, he submitted and received patents for his design in Germany in 1878. And although his theory was sound, there was a problem. The technology available at the time simply couldn't machine Krieger's complex shape, and it would take another 50 years for the screw-type compressor or supercharger to see the light of day. Half a century later, a Swedish turbine manufacturer under the name of Ljungströms Turbin AB appointed a new chief engineer. His name was Alf Lissholm, and at the time he was interested in making highly efficient, highly powerful, lightweight compressors for usage in steam and gas turbines. By this time, the original patent from Krieger had expired, so Alf took the original design, worked on it, and improved it. He not only optimized the profile of the screws, but he experimented and tried different manufacturing methods until he ultimately conceived and patented a manufacturing process for the complex screw shape in 1935. Sometime later, Ljungströmsångturbin AB changed their name into something a bit easier to pronounce, Svenska Rotormaskiner or SRM. Today, these three letters are really well known throughout the world, and this is the company that has issued manufacturing licenses to pretty much every screw compressor manufacturer that exists on planet Earth today. What about the centrifugal supercharger? Well, credit for that goes to Louis Renault. Yes, that Renault. In 1902, he applied for a patent, and in his design he showed and described a centrifugal fan which spun to stuff more air into the intake manifold of the engine, thus increasing the induction pressure. A few years later, Lee Chadwick in the United States decided to put this idea into practice, and he further refined the centrifugal supercharger by creating a three-stage centrifugal supercharger, which was driven by a belt from the flywheel of the engine. He installed these superchargers into his racing cars made by his company Chadwick Engineering Works. Chadwick racing cars were the first supercharged racing cars in the United States, and so the first cars in the world to go over 100 miles per hour. In 1908, a 6-cylinder supercharged Chadwick under the name Great Chadwick won the Great Despair Hill Climb, Pennsylvania's oldest motorsport event. In the same year, Chadwicks ran in the Vanderbilt Cup and in America's Great Prize. In the Vanderbilt Cup, a supercharged Chadwick under the name Black Bess led the race for several laps until, unfortunately, both magnetos failed. This car was timed in pre-race prep at 109 miles per hour. So as you can see, superchargers may have started as industrial machinery, but they very quickly became an important part of motorsports. Racers started to appreciate their ability to act as replacement for displacement since day one. By 1924, superchargers made it to the Indy 500, and around the world, racers in Bugattis, Fiats, Alfa Romeos, Mercedes, MGs, Buicks, you name it, started using superchargers to help them reach one of the spots on the podium more easily. Mercedes in particular found great success with their Grand Prix supercharged cars, while Harry Miller's supercharged Indy cars dominated at the Brickyard. By the mid-30s, the benefits of the supercharger were more than obvious, and everyone wanted the power boost provided by the supercharger. So a man by the name Robert Paxton McCullough decided to capitalize on this, and he started a McCullough Engineering Company. His company became the first large commercial supercharger manufacturer in the United States and began developing supercharger kits for use on passenger cars and hydroplane boats. This was the very beginning of the supercharger kit industry as we know it today in the States, an industry that is still very much alive and thriving. Then came World War II, and superchargers made a name for themselves. Just like turbos, they were used on airplanes to make up for the loss of atmospheric pressure at higher altitudes. Perhaps the most iconic airplane from this time is the Spitfire, with its equally iconic Rolls-Royce Merlin supercharged engine. It was to World War II aircraft what the blower Bentley was to cars. Pure badassery. Speaking of pure badassery, here's something else that's pure badassery. AEM's water meth kits. They're just begging to be added to your turbo or supercharged engine, and they can take your setup to the next level. They are very high quality items that are easy to install and easy to set up, and they look sleek and beautiful in any vehicle. So wave goodbye to knock and say hello to gut churning acceleration. Links down below. After World War II, supercharged cars dominated the newly established Formula One. Perhaps the most memorable and most successful car from these early days of Formula One was the Alfa Romeo 158 and 159. It featured a 1.5 liter straight 8 engine that was supercharged for pretty massive power, and this car won every race in the first season of Formula One. Every race it entered, it won. During the course of its entire career, it won 47 out of 53 Grand Prix events in which it entered. It is one of the most successful racing cars ever made. At the end of 1950, the first season of Formula One, the 158 evolved into 159, with increasingly larger superchargers fitted to its tiny engine. The end result was 420 horsepower in a car that weighed 710 kilograms. I love it when people today say how racing drivers are very brave when they drive their cars all out on a racetrack. Often the testicles of said drivers are said to be made of steel. Now imagine piloting 420 horsepower in the most analog machine ever, steering the equivalent of a bicycle tire in a chassis with the structural integrity of a coffee pot and the suspension of a stool. I wonder what the testicles of drivers like Farina and Fangio were made from. But in the early 60s, Formula One said no more, enough, and thus F1 banned the supercharger. To the dismay of wine lovers everywhere, the supercharger would never return to F1. But although Formula One banned it, Indy 500 never did, and the supercharger enjoyed many successes in the Indy 500. When it comes to mass-produced cars, the addition of a supercharger spawned some truly breathtaking machines, from the small and nimble to the large and luxurious. The supercharger has been a staple of top-tier beasts in the US market for as long as anyone can remember. It's also the magical ingredient in the hellish formula of the Demon, a quarter-mile destroyer. It's the hardest launching production car ever made, and the only production car ever made capable of performing a wheelie. In terms of sheer quantity, superchargers may be losing the battle to turbos because turbos are a bit more efficient and in some cases even cheaper to manufacture. This is why you can find turbos in pretty much anything from 1 liter 3-cylinder economy engines to ultra expensive hypercar engines. But superchargers still definitely have their place and are still preferred by many. They still enjoy the favor of companies like Jaguar, Volvo, or Land Rover, who like to add them to their flagship model engines to spice them up a bit. What about the future? Well, just a few years ago, Audi gave us a possible preview of the future when they strapped the world's first production electric supercharger on their V8 twin-turbo diesel engine in their SQ7 TDI. Instead of being driven by a belt, the supercharger is actually driven by an electric motor. The engine powers a generator, the generator charges a battery, and then the battery runs the electric motor of the supercharger. Yes, it's all very complicated, but it's also very fantastic, resulting in zero lag from 0 RPM. And today we have companies that are offering similar electric supercharger kits for a wide variety of applications. Will they take over as the next big thing? Well, only time will tell. And there you have it, the history of the wine. Not that wine, this one. The supercharger, a beautiful addition to any engine, the lag-free alternative to the turbo. I hope you enjoyed this video and found it informative and maybe even a bit entertaining.